Right, so welcome to another reference table video. This is going to be a video specifically directed at reference table B. So right now you should have your reference tables out, and we're going to look at the physical constants for water. And I feel like blue is an excellent choice when we're talking about water. And so what are these physical constants? So this is, we have the heat of fusion. And I want you to write down on top of the heat of fusion, if I can do this, right? I want you to write the word melt. And that's going to be our fancy word, right? Science, we always got to use these really fancy words just when we, want to say something like, oh, heat of melting. No, we want to say at fancy time, we want to say is the heat of fusion. So the heat of fusion is 334 joules, and then that slash means per gram. So it means that it takes 334 joules of energy to melt 1 gram of water at its melting point. So I want you to write down at, and then I want you to write at 0 degrees Celsius. So water, when it's undergoing the phase change of melting, does not change temperature. It is at 0 degrees. That means it's not changing. If something is at a temperature, it's not going anywhere. It's there. All right, and so this is going to work in conjunction with on table T. So write down table T. And again, I'm still getting used to this whole tablet and pen, fancy tech pen. So table T, this goes with our Q formulas, right? Because Q is for heat. So, and heat is measured in joules. So Q equals, and then M, and then H, and then there's this little subscript F. So this right here is HF. It's not two separate variables. It's not an H and an F, it's HF. So we can see over here, joule, right, is heat, and who wears the joules? I like to say the queen wears the joules, so Q. Oh, it's such a terrible looking Q. Let's scribble that out because it looks like a kindergartner, so I might as well scribble like a kindergartner, and let's practice my skills. I made a much better Q. Awesome. Okay, so let's go on to the next one. Heat of vaporization, right? So we have the clue. I love to pick apart words. We've got the word vapor. So vapor, vaping, vaporizer, right? That all has to do with like steam, and this is gases. So then this is our fancy word for when we convert a liquid to a gas, just boiling. So vaporization is our fancy way of saying boil. What temperature does water boil? At 100 degrees Celsius. So when water boils, the temperature doesn't change. It stays at 100 degrees Celsius. Right? At means does not change. There is no change in temperature. So I can't use the Q equals MC delta T formula because then I would get Q equal to 0, and there's no such thing as zero energy or zero heat. There's always heat going in and out. So this goes with the formula from table T, Q equals MHV. And then that HV number, right, this is HV, that is 2,260 joules per gram. And so now we have the specific heat C for capacity. This is the value. This is the specific heat capacity of water. You learned about specific heat capacity in earth science, but remember, this is the energy required to change 1 gram of a substance by 1 degree Celsius, the amount of energy. So this goes with I'm just going to write that down here. So Q equals MC, right? That's going to be that 4.18. And then triangle means change in temperature. So I'd like you to write down, right, T2 minus T1. And then you're always going to get the correct answer. And again, this goes with table T, right? Table T, make that little T. All right. That summarizes table B, the physical constants for water. If you have another substance other than water, there's going to be different values for the heat of fusion, vaporization, or specific heat capacity, and you would either be asked to solve them or you'd be given those variables in the question. Awesome. Thank you so much. I will see you at our next video.